In all our file reading examples so far, we've read the file in order from start to finish. Recall that we used fgets to read text files from beginning to end. And we used fread to read binary files from beginning to end. This beginning to end linear reading of a file is often quite useful. But sometimes we need to jump around in a file. Perhaps we need to read the same part of a file again, or we need to skip parts of our file. C contains several functions to help us with this task. Let's start with a function that allows us to move around in a file. Remember that every open file maintains its current position. That position determines, for example, where the next call of fread will read from, or where the next call of fwrite will write to. Each read or write call moves the file position. fseek allows us to change that file position. It takes 3 parameters. The first is the stream, whose position we'd like to change. The second is a byte count, indicating how much the file position should change. The third parameter determines how the second parameter is interpreted. Let's see a few quick examples before we move on to a larger example. This command moves the file position to byte 50 of a file. Notice that we use seek set to make the 50 relative to the beginning of the file. In contrast, this command moves the file position to the 50th byte before the end of the file. Here we use seek end to make the 50 relative to the end of that file. This command advances the file position 10 bytes forward from the current position. Note that this time we use seek cur to make the 10 relative to our current position. Moving backwards is similar. We simply use -10 instead of 10. You might think that moving all over a file like this could be dangerous. If so, you're programming defensively. Good thinking. For example, if we try to set the file position to byte 50 and the file has less than 50 bytes, what will happen? In situations like this, the fseek call will succeed, but a later read or write call will fail. So it's particularly important to check for errors in your read and write operations after using fseek. fseek itself can fail if we pass an invalid file pointer, but this can be avoided as long as you check your call to open. We do not check for fseek failure in this video, since the failure cases are better caught before or after the fseek call. Let's look at fseek in action. I've prepared a binary file called 5students, containing 5 student structs. Each struct was written with a first name, last name, year, and GPA, all filled in. The program that creates this file doesn't introduce anything new, so we won't go through that program here. You can look at that program on your own if you're interested in an example of a program that uses an array of structs to create a file containing multiple structs. We will use fseek to help us move around that file in response to user requests. Let's first look at what the desired program does, and then look at the code. The program tells us to type -1 to exit, or to enter the index of the student we wish to view. Let's type 3. We see student information for a student named Daniel. Let's type 1 now. Now we see information for a student named Michelle. Let's type 1 again. Michelle's information showed up again. So clearly we were able to read the same location in the file a second time. Let's type 8. This is invalid because there were only 5 students in the file. Notice that the program detects the error. Finally, let's type -1 to exit. The program is retrieving individual student structs from the file. It's using fseek to move the file pointer's position to the desired student, and then using fread to read the student. Let's see how it's done. The top half of the file should be familiar. We're declaring struct student and defining a few useful variables. Next, we open the file 5students as a binary file and error check the fopen call to make sure that fseek will be operating on a valid file pointer. After providing instructions to the user and reading the index of the first student, we enter a while loop. This while loop uses fseek to move the file position to the byte where the desired student begins. Notice that we multiply the number of the student by the size of the student struct. Forgetting to multiply by the size of the struct is a common error. If we don't do that, then we will end up moving the file position to a particular byte, not to the beginning of a struct. It's possible for the user to give an invalid number for the student to read. In that case, fread will fail, so we error check the fread call here. Finally, we print out the student that was successfully read. You might wonder why we use fseek at all. Couldn't we have just read all 5 students into an array at the outset and then index that array appropriately? In this case, yes, because the file is very small, only 5 structs. But consider a huge file of millions of structs, which can easily happen when handling large data sets. In that case, it may be infeasible or impossible to load all of it into memory at once. That's where fseek can save memory and provide a convenient means of pulling out only what we want from the file. Rather than moving around arbitrarily through a file, it's also occasionally useful to move to the beginning of a file. You might do that, for example, if you wanted to read the entire file again. You can do that using fseek by supplying a value of 0 for the second parameter and seekset as the third parameter. But for this specific case, there is an easier way. The function rewind can be used to move to the beginning of a file. It takes only one parameter for the stream and returns nothing, so it is simpler than using fseek. Of course, for any other kind of move through a file, you'll want to use fseek.